Hello, this is Mr. Painter with another fabulous Quizzette tutorial. Today we're working on Tuesday for Quizzette 841 on exponents. Now, double check from yesterday that your name, date, team, and color are listed on top of the paper, even though it might be on the front page of the packet. If that front page of the packet disappears for whatever reason, and your name is not on the Quizzette, I cannot give you credit. Okay, getting started for today. We are on Tuesday. Alright, it is always helpful to read the directions as well as use the steps from yesterday to continue on your task. Your task today, find the missing value to make this equation true. We have Mr. Bush to the third power times something gives you Mr. Bush 2 to 39 power. Yes, Mr. Bush will be our sponsor for today. All right. On this one, you guys know, we're going to go blue today because it's Tuesday. I'm not worried about the Bush part. We are worried about the exponent. So we have an exponent of a 3, a something, and a 39. So all it did was bring down the 3, question mark, and 39. Now, what do we do with that information? Well, remembering the rules is if you have an exponent on the inside of the parenthesis and an exponent on the outside of the parenthesis, you automatically need to know that is multiplication. And here, between the question mark and the 39 is an equal sign. So what you need to figure out is 3 times what takes you to 39. Little bit harder, but same steps as yesterday. Take the opposite of multiplication and divide 3 from both sides. Now, 39 divided 3 looks a little bit new to you, so what you can do is you can work it out on this side. 3 and 2, 39. In order to divide, take your 3 and divide how many times 3 goes into 3. Well, 3 and 3 is a match, so that can go 1 time. 3 times 1 is 3, and we bring that down. So 3 minus 3 is 0, and bring down the 9. Now ask yourself, how many times does 3 go into that 9? Oh, yes. 3 goes into 3 1 time. Yes, 3 goes into 6 2 times. 3 goes into 9 3 times. Oh, 3 times. So 3 times 3 would give you 9, and that 3 that we're using goes on top. So therefore, the missing value of 39 divided 3 is 13. Number 2, find the missing value to make this equation true. Notice the bases are the same. We have a 4, and a 4, but we have a series of thrilling, exciting exponents. All right. Okay, so I'm not worried about the 4s because I'm just not worried. All right, I'm worried about the question mark. I'm worried about the 7, the 4, and the 32. So now I need to figure out, well, what do I do with this information? Well, we've got to remember the rule is if your exponents have the same base and they are on the inside of the parenthesis, that is the rules of addition. And it's also inside the parentheses, so I'm going to leave it inside the parentheses there. Now the 4 on the outside, remember from yesterday, what was the rule that when an exponent is on the outside of the parentheses, what was the rule that you had to do? Think about it. Yes, the rule was multiplication. And the last part here is pretty self-explanatory. Bring down the equal sign. So now what we're asking ourselves is we're looking for the missing value from here, which is the question mark. So something plus 7 times 4 has to give you 32. Well, it's kind of long and confusing, so let's start breaking it down by taking the opposite. The opposite of multiplication comes first before the opposite of add and subtract. All right, let's do it. So let's start with the opposite of times 4. So we're going to divide 4 from both sides. So divide 4 divide 4. So now we have something plus 7. 4s are out, equals 32 divide 4. Oh man, 32 divide 4. Okay, so 4 times 1 is 4. So I'm gonna do by 4. So I got 4, 8, 12, 16, 20, 24. 24, another 4 is 28, another 4 is 32. Oh, 8 times. That's not too bad. So 32 divide 4 is 8 times. Let me reiterate, gotta try to do this without a calculator, because the calculator on the next test probably will not be there. But 4 and 32 is not bad, because all you gotta do is know your 8 and your 4. So 8 times 4, 32. Okay. Alright. Oh boy, something plus 7 gives you 8. See how it just got really easy? In case you're still a little bit confused, do show the work. Minus 7, minus 7. 7s are out. Question mark comes down. Equals 8 minus 7 is 1. All right, number 3. What is the product of the equation below? They're being so kind to you, and they're telling you the word product has to mean multiplication. So we got to multiply this out. So what I'm going to do is ask you from yesterday, what is the first step? Take a look at it. What would you do first? Yes, if you said we got to do 8.9 times 6 first, you're absolutely correct, because that's what I'm going to do. 8.9 times a 6. All right, well, let's do it. Basic multiplication, we got 6 times 9. I believe last week I made a mistake on that, but last time I checked, 6 times 9 should be 54. 54, so 4 goes down, 5 goes up, and 6 times 8, 6 times 8, 6 times 8, what could that be? Oh yeah, 6 times 8 is 48 plus 5, 49, 50, 51, 52, 53. So 5, 3. All right, something don't look right. How is it possible that an 8.9 times a 6 is a huge number of 534? I mean, think about it. 8.9. So if you think about it, like really 8 times 6 should be in the like maybe 40s or 50s something. Oh, the decimal. That's what it is. The decimal is causing the issue. So if I move the decimal over to the one place to the right, I have to move the decimal over one place to the left there. So 53.4 is our 8.9 times 6 times, so we have multiplication between tens to the third plus 5. And go ahead and make those connections. So again, we got 53.4 times 10 to the 3 plus 5 for that exponent right there. So 2 more steps. Clean up the exponent right here, do the 3 plus 5, and scientific notation, clean that up so it's one place over from the left. Okay, here we go. So 3.4. So 53.4 times 10, and that should be a big 10. 3 plus 5 takes me to 8. I'm almost done because I need to move the decimal only one place to the left, because we need it one place from the left. So 1 should be right there. So go 1, add 1. So final answer is 5.34 times 10 to the 9th power is our solution there. So we call this either in 3rd grade terms, we call it an answer, a solution, the value, but this is the solution, value, or answer in scientific notation. So scientific notation, which you're gonna work on this week. All right, number 4. What is the sum of the equation below? Now, notice how you can tell the difference between number 3 and number 4. The sum, it'd be better with the highlighter. Good old highlighter. There we go. The sum means add. So that means we need to add. So add, where number 3 was multiplication over here. So multiply. So write that down, please. Write down multiply for product. And for sum, write down add, because this vocabulary is key to understanding why this one and this one are different. Because one's add, one's multiply. The rules of adding mean stay inside the parentheses. So what we have here is 4.8 times 10. So we don't even need the times. And times 10 to the first power, well, it just means move the decimal over 1. So 4.8, 1 time, guess what? 48. Now you've probably been wondering, well, why does that rule work? If this means an exponent of 1, 10 to the 1, that means only 1/10. So yeah, we really don't even need that. So literally, if you do 4.8 times 10, that is 48. That's why that rule works. So if you use a calculator, which you don't need to because we're moving the decimal instead, 4.8 times 10 to the first is 48. 4.8 times 10, 48. That's why that works. Plus 3, 1, 2, 3, because of that 3 right there, 3 places over. So we have 3 zeros, 1, 2, 3. Why does that work? Because if we break it down, it's really 3 times 10 times 10 times 10. So what I didn't show you on the notes yesterday is why this number works so the decimal moves. So 3 tens, 3 times 10 times 10 times 10 is 3,000. That's a lot to do in a calculator, or even on the side, doing 3 times 10 is 30, 30 times 10 is 300. Oh, 300 times 10, 3,000. That's how I got that. That's not a big deal. Your beautiful addition problem of 3rd grade, it's kind of a bigger problem. So, yeah, I'll call it 3rd grade. So let's just take the 48, put it underneath there, and just add it, because it says add. Always add. See this right side right here? Lining up to the right side. So 0 plus 8 is 8. 0 plus 4 is 4. 0. It's all by itself. It's 0. And 3 comes down. It's 3. So we got 3,048. Actually, for scientific notation, this makes it pretty simple today. So we got 3048, so 3,048. The decimal is located where in 3,048? Where is the decimal? Because I don't see it right now. Yes. If you said it's on the far right side, because it is. So we do need to move it over, so it's only one place from the left. So it looks like we're going to go 1, 2, 3 times to make this happen. 1, 2, 3 times right there. All right. Beautiful. So 3.048. Now we do use all the numbers because there are no zeros after this decimal place. So you just use everything. So 3.048 times 10. To how many places you moved it over. So again, 1, 2, 3 times. 10 to the 3rd takes you there. All right, number 5. Oh my God, this beautiful problem again. Okay, careful on this one. Careful, 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 because it says select all. So that's already going to tell you there's more than one right answer in here, if not multiple. It could be 3, 4, all of them could be right. So take your pencil and circle that, select all, because that's critical. Don't just pick the first one you think it is and move on, because you're going to get it wrong. The word equivalent means, write this down, means the same. The word equivalent means the same. The same. All right, so what we want to do is we want to find out which of these here are the same as this here. So what I'm going to do is I'm just going to work it out on the side. So we got 4 negative 7 times 4 to the 5th power. Give it a set of parentheses to the 1st power. Because these two have the same base, the number in front of the exponent is the base. The little smaller number up in the sky we call exponent. And we have something called a power rule when it's on the outside. Okay, so we have 4 negative 7 plus 5, because they're inside the parentheses, times 1 on the outside. So now I'm there. So you got to think to yourself, negative 7 plus 5, because you do what's in the parentheses first. Negative 7 plus 5. I am definitely noticing, and you probably noticed it too, you saw it. Well, negative 7 is much larger than that 5. Negative 7 is much larger than that 5, as in the number itself, not the negative. So this number has to be negative. So if you got $5 and you lose $7, because Mr. Mejia took it just like yesterday, that's going to take you to negative 2. So we got 4 negative 2 times 1. So 4 negative 2 times 1 is 4 to the negative 2. The part that you got to remember is whenever you have a negative exponent, that changes into a positive fraction of 1 over 4 to the positive 2. Your IXL this week will help explain the negative going into a positive on the fraction. So we have 1 over 4 to the 2nd power, and just finish it out. So 1 over 4 times 4, because that exponent of 2 does mean 2 fours, so 4 times 4. And 4 times 4 is, I think you got it, 1 over 16. So we're going to stop there. That's as far as you can go. So we do need to take a look at 1, 2, 3, 4, 5, 6, 7 steps and see where they match up in these right here. So we're going to start out with G. Did we see a 4 to the negative 1st power? So no, 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 no. And these are all fractions down here. So G is out. So no. All right. 4 to the 2nd power. So no, no, no. There it is right there. So 4 to the 2nd power, 4 to the negative 2nd power did work. So that is actually one correct answer there. Next, negative 4 by itself, I don't think ever happened. These are all positive, 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 positive. Yeah, so negative 4 by itself never happened. So that's out. Don't pick that. J, the 1 over 16. You see it in the list anywhere? Yeah, see, you see it at the bottom, right? So 1 over 16 is 1 over 16. So that one is a correct answer. So that one's good. Take a look at K. Do you see 1 over 8 anywhere? So looking for the 1 over 8. Now, there is absolutely no 1 over 8, but be careful. Students might say, oh, well, 4 times 2, Mr. Painter, is 8. That's 4 times 4, because that's 2 4s. So be careful. That's where this right here could be a trap answer. So 1 over 8 is not a correct answer. And the last one, we just need to work out and see if it matches. So you do 6 minus 3 and see if you get a match. So here we go. We got 4. 6 minus 3 is 4 to the positive 3. So 4 to the positive 3 here, I don't see it anywhere. I don't see it anywhere actually at all. So actually K, L is out too. So we only got H and J that work on that one. So no and no on those two. They don't work. Okay, going on to our last one. This was, remember from yesterday, one of our easier problems. How many times greater is 6 times 10 to the 4th power than 6 times 10 to the 5th power. So in this one, I do see an issue. In order for the first one to be greater, the exponent has to be larger than the second one, and it's not. So once again, we're going to go ahead and correct this problem. So go ahead and cross that out and change it to, basically switch it. So we got 6 times 10 to the 5th, then 6 times 10 to the 4th is how it should be written. It happens, but that's the way it should be written. All right. So this one we have division right after we do our multiplication of course. So we got 6 times 10 to the 5th is 6. 1, 2, 3, 4, 5 zeros. Versus, it's like a match, right? 6 times 10 to the 4th, 1, 2, 3, 4. 1, 2, 3, 4. So dividing it out, stay with 6 divide 6 is a 1. And eliminate 0. So that 0 crosses out with that 0. 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 And we have 1 0 left here. So guess what? Hey, 10 times greater. 10 times greater. That's your solution right there, because it's asking for how many times greater right here. All right. This concludes your Quizzette for 8/41 Tuesday. Have a great day.